And yeah, I realize that I'm the last person left between all of you guys and other pursuits, so I'll try to make this quick. I think this will be easy though, because a lot of the things that I'm going to talk about have already been talked about in this session. So a lot of some of the agent-based modeling and the visibility stuff that I've been harping on. So some basic organization before, so I don't get bogged down in the process. Basically, I'm just going to talk about why I'm building the model. So the model's being done in support of my PhD. I'll talk a little bit about that. I'll talk about how the model actually works. I'll talk about a little bit about the data I'm getting from the model. So the model's running right now, knock on wood, back in Oxford, but I've got a little bit of data that I can share with you guys. And then I'm just going to talk very briefly with the time I have left about my ideas for improving it and maybe moving it forward. So we're returning now to Iron Age Britain. We saw Brochs earlier, which were concentrated mainly in Northern Scotland, entirely in Northern Scotland. What got me interested in doing this model was looking at coastal defended enclosures, also known as promontory forts or rats or duns, depending on where you are and what you study. And what I found, things I found looking at those sites was that there's kind of an assumption that maybe they were probably prominent from the sea. There's a suggestion that maybe people were using them to navigate, but no real way, not many ways to test that, with a couple of sessions that I'll cover later. And that's kind of crucial because when we talk about the Atlantic Iron Age, people have talked about an Atlantic zone, so we know that materials are moving up, we know that ideas are moving up and down the coast. So potentially the placement of sites could be a very crucial part of that system. If they're being used for navigation or if they're being used for another related purpose. So yeah, here's some examples of people thinking about the Atlantic zone in terms of routes or just in terms of contacts. The exception to which I previously alluded, this is work done by Sean McGrail. He was looking at a lot of documents describing rowing voyages across the channel, and he was comparing that with his own knowledge to try and work out how long his crossings would have taken, whether it was a sailing season. And I kind of want to take that approach and expand on it to ask some other questions. So again, we return to the sailing season. I'm also interested in trying to find out how difficult the crossing might have been. I think that's an interesting question and definitely a relevant one, given that given that if you look on the eastern coast, the crossing is very short, whereas the crossing from Brittany to Cornwall and Devon is much longer. You would have been out of sight of land, and what I'm wondering is if there's sorry, it's the end of the day. I'm wondering if part of the reason why these routes might have been less traveled is because they were just more difficult to cross, and not just because the distance is further. So these are the coastal nodes or the points of origin and departure that I'm looking at. I'm basing this on work done by Eileen Wilkes, identifying sort of coastal nodes, potential harbors along the southern coast of England, and I basically just applied her criteria to the southern half of the Western Channel. So to get a handle on these voyages and to assess the risks, basically what I'm doing is I'm running the model, that takes a set of input parameters, which I'll discuss, and I'm going to vary those parameters to try and understand how much they affect the system, the model system. So some of the parameters I'm varying are starting and ending points, so these coastal nodes, the date, so I've collected data ranging from the beginning of March to the end of September, so I can run simulations for each day in that period, and I can run simulations at different times. Ship performance, yes. Okay. So I've got a couple potential parameterizations for an Iron Age boat, again taken from McGrail's evaluation. Sets of landmarks. So I have sets of these sites, these coastal defended enclosures. I've also got a set of just generally prominent points that I determined using GIS. And then finally, one of the things I'm varying in the model is the ability to read environmental conditions, the ability to recognize those landmarks, whether or not they're visible, and I want to see how that affects the navigation. So just going back to the model, this is a generalization, but modeling movement by sea has generally tended to take the form of a least cost path model, where you're looking at you're using cell-based method, or you're looking at isochrones, and you're trying to find an optimal route between 2 points. Other models basically are essentially agent-based in the sense that they perform calculations to do with the strength of the wind, say, or the current, but then the user is the one who selects the heading, who's basically the agent in this model. And when going into this, one of the problems I had with looking at a sailing model is, especially one that has to do with navigation, is that there are some things that are difficult to parameterize as cost, right? I mean, some of these models do a very good job of doing that. It was something that I felt a little bit uneasy about. So I ended up, instead of trying to take the lid off a least cost path model and adapt it to what I need to do, I decided to go with the agent-based model. So basically, instead of having a user who's making the selection, I have the script. And I'll talk about, that's another example. So this is the results of one of these these agent-based models. So I'll talk about how that actually works. So it's written in Python. It executes ArcGIS tools. ArcGIS handles most of the 3D stuff I'm doing. And basically, it gets fed parameters and then attempts to navigate between the 2 points that are specified. The outputs are plots, mainly just so I know that it hasn't gone completely off the rails, and a set of logs. So the logs detail environmental parameters at each position along the voyage. It also details how visible each site is and the degree of visibility. So as far as data sources, the most important ones are the environmental data sources. So I'm using a NetCDF, which is similar to a multi-dimensional raster. I've got these from the French Navy, essentially, and they have data on wind direction, wind speed, current direction, wind speed, tide height. I also use the shipping forecast, which, if you're not familiar with that, is a British radio program that records sea conditions. It's especially useful for visibility, so we saw visibility classifications used in other studies. They got their own set, and they're designed for mariners, so I found that very useful. And I also use a DEM derived from SRTN data to perform visibility analysis. So in terms of actually working out where a boat will go, I'm essentially referencing a polar diagram. So you can see an example of a polar diagram on your right. Essentially what they chart is the speed that a vessel can achieve in optimal conditions given its relative angle to the wind. And basically these arrows that I've drawn represent the different parameterizations that McGrail has suggested. So what the script does when it's simulating is it's getting the wind direction and speed, it's represented as a vector, and then it's comparing that to that polar diagram to work out what the speed of the vessel would have been. So we're going to attempt to walk through a run here. So basically, to start out, the script generates a 5-degree array of possible headings given a set of what I'm calling reckoned environmental parameters in a polar diagram. I'll come back to reckoning. The endpoints of these arrays are converted into vertices in what I'm calling a heading envelope. They represent the area that the simulated agent believes to be reachable within the time step, which in my case is 1 hour, given the resolution of my environmental data sets. Then for each vertex in the heading envelope, the script checks the proximity of these points to the sort of reckoned destination. And basically, because I'm trying to simulate dead reckoning, if no sites are visible if no sites are determined to be visible by the script, then it estimates where it thinks the destination is based on an estimation of the ship's speed and bearing. The proximity in this case is determined by a fairly simple convex path analysis. So the problem that I was running into was that if a ship enters a bay and you're judging every vertex just by the straight line distance between the ship and its destination, you can end up trapped in bays or around headlands. All this does is it clips obstacles, selects the smallest part of the clipped obstacle, and uses the vertex in a convex hull for that part to draw a new line. So the heading is selected basically. The heading that's selected is the one with the shortest convex path to the destination point. Okay, and then it repeats. see that there. So in all of these, basically, it's not looking for landmarks, which is why it's drifting a little bit. The destination point is drifting a little bit, I mean. In this case, when you are looking for landmarks, basically the script uses 3 different layers of visibility analysis. Thank you. Which I'm going to have to hurry up. So uses 3 different layers of visibility analysis. Basically, the first one is just checking whether it's within range. The second one is doing a skyline and just making sure that the site isn't completely invisible. And the third is it's a volumetric visibility analysis. And essentially, if you're familiar with computer graphics terminology, I've built a rasterizer inside GIS. If you're more into architecture, then I've basically, it's a type of 3D isovist. You can see an illustration of it there. Basically what I'm doing is creating a 3D radial array and projecting it at a site, and then I'm sampling rays in that array to determine the projected extent of that site. So I'm quantifying how big it appears to someone rather than whether or not its area is unobstructed. And this was mentioned in a question, but it's an important index of visibility. And given the nature of the coast, so how rocky it is, I think it's the most important one when you're talking about the visibility of sites as landmarks. So again, if 2 landmarks are visible, then the script passes the real location of the destination to the agent instead of reckoning it based on speed and direction. And there we go, it's finished. So just some preliminary results from an analysis I ran a few months ago. Basically, I just focused in on one route, one that McGrail looked at from the Isle to Mount Spey. And so I did a few runs for each day in the study period, trying to see if there would be a big sailing season. It doesn't look like there was from the data. The one thing I can see is that there is a 3-week period when generally the average time is low and the runs are generally successful, which is interesting. And I'm working out how to sort of dig into this data. But it raises the possibility that the sailing season might have been very short or that there maybe were multiple small ones. The second analysis, I varied the ship type. And really, between the parameters for the 7-meter and the 12-meter vessel, it didn't seem like there was a huge difference, which kind of interested me. And it's definitely something I'm looking at as I get basically drip-fed the data from the main analysis. So next steps, again, is getting the results and interpreting them. I was kind of hoping with the small analysis that something would be pointing to like a real clear scenario for what the crossing would have been like. This is sort of me mulling over what those scenarios might be. But it didn't really seem to point to any of them, so that's something I'm interested in. So again, I'm planning lots of simulations, and I'm hoping to pull conclusions out of that. Just read through that. Okay, so just thinking ahead to maybe some possible improvements. So this is going to come as a surprise to no one, but processing time is annoying. It's a limitation on the amount of analysis can be done with this script, mainly because of the 3D visibility analysis I'm doing. If I wasn't interested in the visibility of landmarks in themselves to try and say something about these promontory forts, I think I could speed it up and I could do different types of analysis with it. But it's cool to see more work being done on visibility. It's cool to see more work being done on navigation modeling, because now we can start to compare these models. We can start to see how the different people's designs do with similar inputs. It's something I think that really needs to be done in this particular niche. And then, I've kind of created an opposition between least cost path and isochrone modeling, but there's definitely elements of either that can be pulled into the other one. I'm sure that made sense. There's definitely potential for cross-pollination between the two. There's definitely innovations that LCP modelers have come up with that I hope to work into future models, and I hope vice versa. Thank you very much.